In this lesson, we're going to be talking about the type of transformation called a reflection. The best way we can describe a reflection is taking a figure or a point and flipping it over, or flipping it over a specific line that we like to call the line of reflection. And the line of reflection is basically the line that a point or figure is reflected over to create a mirror image of the original figure. Let me show you what we mean here. So I have here that a reflection over the x-axis means that you're taking the coordinate x, y, and you're flipping it over the x-axis to get a new coordinate x, negative y. Let me show you what this means. I'm just going to go ahead and I'm going to choose this coordinate right here. I'm going to call it A. This is my pre-image. Notice that it is in the quadrant that is both has a positive x value and positive y value. So I could actually write off to the side here that my x value is 3 and my y value is positive 2. Now, I'm going to go ahead and reflect this over the x-axis. The x-axis is the axis that is in pink. So here's how I do it. I'm going to put my pen right on the dot that is of my pre-image, and I'm going to count the spaces that this point is away from that pink line of reflection. If I walk towards the line, you can see that I'm 2 spaces away. Once I reach the line, I'm going to go 2 spaces in the other direction, 1, 2. And then I'm going to go ahead and write my new image, which is A prime. Notice that the coordinate of this point is going to be 3, negative 2, just like we stated up at the top. Okay. That's translating over the reflecting over the x-axis. Now let's go ahead and reflect over the y-axis. So I'm going to go ahead and just choose another point. I'm going to choose the point 1, 4. I'm going to go ahead and call him B. So 1, 4 is going to be called B. I'm going to reflect him over the green line, which is my y-axis. So I'm going to run 1 space to the line, and then I'm going to run 1 space away from the line. And I'm going to indicate my new image by the name of B prime. The coordinate of this point is going to be negative 1, positive 4. Notice how my x coordinate is the only one that changed. So these are the baselines of a reflection. Let's go ahead and talk a little bit deeper about how to reflect a figure. So in these problems it says determine the location of the point or figure after the given transformation. So it says a reflection over the x-axis. Personally, whenever I'm given a problem like this, I always like to grab my highlighter and I just like to highlight my x-axis. It's kind of a big highlight there. You might have a smaller highlighter, but that is going to be my, my line of reflection. Let's see if I can make that a little bit smaller here. Sorry for the delay. Let's try that again. Seems like a little big. There we go. That's much better. Okay. So I'm just going to go ahead and highlight that line just to remind myself that I want to reflect it over the x-axis. Okay, let me go ahead and change my pen color. All right, just like we did with our translations unit, we want to go point by point reflecting each one of these points across the x-axis. So I'm going to go ahead and start with my y here, and I'm going to count how many spaces away it is from that line of reflection, which is just 1 space. So I'm going to run towards the line, I'm going to run away from the line. And I'm going to call him y prime. Then I'm going to move to my x. I'm going to count 1, 2, 3 spaces away from the line, and then 1, 2, 3 spaces away from that line again, and label him x prime. And then my last coordinate z, I'm going to count 1, 2 spaces away from the line of reflection, and then 1, 2 spaces away, and I'm going to call him z prime. At this point, I can go ahead and connect my dots. And I'm done. I've reflected my image across my x-axis. Let's try another one. Now, you'll notice in number 1, it was a nice clean reflection, meaning I had all 3 points in the second quadrant that ended up in the third quadrant. Well, in this next example, it's going to look slightly different. Let me show you. I am going to start by identifying which axis I'm going to have as my line as reflection. So again, this is going to be my x-axis. So I'm going to go ahead and just highlight him. It just takes a second to do that. And then what I'm going to do is I'm going to reflect. So I'm going to go point by point. I'm going to start with the L. Notice how the L is in the second quadrant. Just like before, I'm going to run towards the line of reflection. So I'm going to run 2 spaces towards and then 2 spaces away, leading me with the coordinate right here. I'm going to label him L prime. Remember to label your coordinates and your new images in the moment and don't wait till the end. All right, the next coordinate I am going to reflect is going to be P. Notice how P is not only not in a quadrant, but it's on the other side of our line of reflection. That's okay. You're always going to want to run towards the line of reflection. So I'm going to run towards that line, 1, 2, 3 spaces, and then I'm going to run away 3 spaces, 1, 2, 3, leaving me right here. And I'm going to label him P prime. Now my J, go ahead and put your pen on that J, and we're going to run towards the highlighted line. I'm going to run towards it 1 space, and then I'm going to run away from it 1 space, and that's going to be J prime. Now that I'm done, I'm going to go ahead and connect my dots, and you can see that the reflection looks a little bit different than the previous example that we did. But this is indeed a reflection across the x-axis. Okay. I bet you can guess where we're going next. Now we're going to look at the y-axis. So it says determine the location of the point or figure after the given transformation. This time we want to reflect it over the y-axis. So before I begin, I'm just going to indicate that I'm going to go over my y-axis and I'm going to go ahead and highlight it. Trust me, it's a really good tool to just help you remember how to reflect those points. All right, let me grab my pen. Let's go ahead and reflect this figure over the y-axis. You can start at any point that you choose. I'm going to start with the E because the E is the only point on the right side of the line of reflection. So I'm going to start with him. Again, I'm going to run towards the line of reflection, 1, 2, 3 spaces, and then I'm going to run 3 spaces away, 1, 2, 3. I'm going to draw myself a dot, and I'm going to label my new image E prime. Now I'm going to move to the left side of the line of reflection. I'm going to work with the V. I'm going to run towards the line, 1, 2, 3, and then I'm going to run 3 away, 1, 2, 3. There we go, V prime. And then the last one is going to be N. I'm going to run 2 spaces towards the line and then 2 spaces away. And I'm going to label him N prime. And now that I'm done, I can go ahead and connect my dots, and I have a nice reflection over my y-axis this time. And the last one here, let me go grab my highlighter. And again, I want to go over the y-axis. So I'm going to go ahead and indicate that y-axis on my coordinate plane. And just like we did before, we want to go point by point. So I want to start with L, and I want to start with L for a reason. Notice how L is on the line of reflection. If it's on the line of reflection, then it's no spaces away from the line of reflection. So you actually aren't going to move it. You're just going to leave him by itself. Personally, I like to put a dot right on top, and I like to label him L prime because technically that is my new image. All right, let's go ahead and move to J. J is going to be 3 spaces away from my line of reflection, so I'm going to run towards the line, and then I'm going to run away from the line. And I'm going to label him J prime. And then P, I'm going to count 2 spaces away from the line, and then 2 more spaces away from the line. And I'm going to label him P prime. And I'm done. I can go ahead and connect my dots. You'll notice that they kind of coincide with the pre-image, but that's okay. And I have reflected this line over the y-axis, or this triangle over the y-axis. All right, the last question I have here, it says, which of the following transformations could not have been created by a reflection? Choose all that apply. Go ahead and pause the video here and see if you can determine which ones were not created by a reflection. Okay. So, things we need to remember. We need to remember what a translation is. Remember, that's sliding a figure across the coordinate plane. And then the new information that we learned today, a reflection. This is a flip, so we're flipping it over a given line. So if you look at number 1, this does not look like it was necessarily flipped over the line because it has some vertical movement as well. So this is not going to be one of our answer choices. Actually, it is going to be one of our answer choices, but just like we did before, let's go ahead and determine which ones are created by a reflection. That'll help us determine which ones are not. So if we look at the second one here, we can see that this one is definitely going to be flipped across my x-axis here. So this one is going to be a reflection. Okay, and then the next one, it looks like this one was reflected across my y-axis. Now, you might be thinking, couldn't this also have been a translation? And you're absolutely right. Sometimes a translation can look like a reflection, and this would be the perfect example of showing that. But in this case, it definitely could have been created by a reflection. All right, the fourth coordinate plane here, you can see. Now, you can see that the square has been shifted, not only vertically, but horizontally. When that happens, a reflection did not occur. So we're not going to go ahead and circle that one for right now. The next one, you can see that the triangle is facing the same location, or it has the same position, meaning the arrow is kind of pointing to the left, and therefore it has not been flipped. So this one could not have occurred by using a reflection. And then the last one, this one's a tricky one because it kind of looks like we're reflecting it over the x-axis, but you'll notice that if we did reflect it, the triangle would be the other way, right? Because we would have to have flipped it. So, as we can see, there are only 2 that have been created by a reflection, and those are the ones that we indicated. But the question said, which of the following could not have been? So I'm going to go ahead and circle all of the other ones that we talked about. Alrighty, and that's all we have to talk about reflections.